In today's session, we are going to see NumPy. Okay. In the previous sessions, we saw how to create arrays, right? We saw list, tuple, dictionary, right? We saw different ways of creating arrays. Then we saw conditional statements. Uh, we saw for loop, while loop, right? Else, else if, else. How to do that. And we also saw the most important functions, right? So continuing with that, we are going to see NumPy. Okay. What is NumPy? NumPy is a Python library used for working with arrays. So we already saw how to create arrays. So NumPy is another way of creating, manipulating, and working with arrays. NumPy stands for numerical Python. Okay, we use it as NumPy. So in Python, we have lists that serve the purpose of arrays, but they are slow to process, right? That's what we saw earlier. No, we saw different types of arrays, but they are slow to process. NumPy aims to provide an array object that is up to 50 times faster, okay, than traditional Python lists. Okay. Arrays are very frequently used in data science, where speed and resources are very important. This is another way. Okay. If you see, we have been seeing how to manipulate data. That's what we have been seeing, right? So the whole idea is once data is there, it's going to be represented in the form of arrays, right? And you are going to work on them. You're going to add, you're going to delete, you're going to manipulate so that you can develop ways of determining patterns, right? And then you build your statistical model. So why NumPy is faster? NumPy arrays are stored at one continuous place, okay, in memory, because computer has got memory, right? So NumPy arrays are stored at one continuous place. So processors can access and manipulate them in very efficiently. Okay. This behavior is called as locality of reference in computer science. Okay. So this is the main reason why NumPy is faster than list, because we want faster, right? Also, it is optimized to work with latest architectures in our computers. So which is why we use NumPy. We are going to see one more possibly today or another session, pandas. Okay, that's another way of working with arrays. Okay, so let's see NumPy in this session. So getting started with NumPy. Once NumPy is installed, how will you do it? You import it in your applications by adding the import keyword, right? This is a library. This is a built-in function, right? You are accessing it. Import NumPy. Okay. Another way of doing it is we use an alias. Alias is another name, right? You have a name, right? You have a full name. You also have a short name, right? So alias is like a short name, another name. We use that using the keyword np. So import NumPy as np means NumPy is imported, okay, and we are going to use it. So creating an array, I've just given AR, okay, for array. NumPy.array 1, 2, 3. Okay, 1, 2, 3. And then I print it. So all of you please try it in Google Colab as we are going through this. As you can see here, as soon as you type import NumPy as, is it NumPy as NP? Google Colab is prompting. See, it is making your life easier. What is the one thing that I am not doing in writing codes here? I talked about it in previous sessions. Right. I am not using hashtags. Right. But please make sure you are using hashtags. Why you have to use hashtags? That's a better way of organizing your codes. If you see the codes after a couple of months, or if somebody else sees your code, it can be for the purpose of enhancements, it can be for the purpose of even debugging. The other person should understand what you have written. If you have written 1,000 lines of code, it is very difficult to understand, right? So hashtags helps us to understand what is what. It's only for better organizing, and Python will not process that once you put it in the form of a hash. Okay, suppose if I make a mistake, in fact while I was creating this I made a mistake. Instead of a comma, I put a dot. See, it says invalid syntax and it's even pointing to it. I'm creating what is known as a two-dimensional array. Can you see it? What we saw earlier is a one-dimensional array. What we are now creating is a two-dimensional array. Clear? Okay. The other one is what is known as ndim. Okay. Using this, you can find out how many dimensions are there in the array. For example, this one, there is only one dimension, right? Or what is called as zero dimension. So when you come to this one dimension, the other one, this is a two-dimensional array. Can you see it? It is like I'm writing your student ID and name. Okay. So just like how we saw in lists, you can create an array and you can access an array and you can print it. Very useful, right? Very simple and very useful. Because in all of data science, we are going to be referring to data that are stored in different tables, in different files. You're going to access them, you're going to process them, you're going to manipulate them. Using, we already saw lists, we already saw different ways of creating arrays. What you're seeing here is NumPy. This is an extension of that, right? NumPy is faster, which is why we are using NumPy. And we are going to see in a subsequent session another way of creating arrays, another way of working with arrays, what is called as pandas. Okay. Is this clear? So how will I access the details? It is similar to how we saw previously, right? So import NumPy as NP, this is what you say. Import NumPy as NP, this is what you say, right? You're creating an array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is similar to student ID and name, right? And if I have to print the third element of the first dimension, right? It's a two-dimensional array. I say 0, 2. Clear? Is this clear? Very similar to what we saw, in list, tuple, dictionary. Very similar to that. Okay. But instead of other ways of creating arrays, here we are using NumPy. As I said, why we are using NumPy? This is faster. Okay. You may be wondering why we have to study list, tuples and all. I can come directly to NumPy, right? No, it doesn't work that way. You have to go step by step. 1 and 2, there is something called as appropriateness. When you don't need something to be processed faster, you don't have to come to NumPy. You can use other means of doing it because you want to conserve resources, right? Because another one is an even a better way of handling databases, tables and all is what is called as data frame. That is what you're going to see in pandas. So it depends on your need, right? It depends on your need. See, this can be an interview question. Someone can ask why there are different ways of creating arrays. The answer is it depends on what you want to use it for. The appropriateness is very important. So we are using NumPy because it is faster to process, right? And just like how we saw, in creating arrays, you can access using the negative, that is from the last. So last element from second dimension, this is 10. We are trying to access this. You're trying to access this. Okay. And I can print, the ones from 1 to 5. Right? Remember, we start with 0. Any arrays, the storage starts from 0. Right? So it is 0, 1, 2, 3 up to 9. That is where it is stored. So if I am printing 1 to 5, it is actually starting from here. Right? And it is actually starting from here. Can you tell me why 6 has been left out? Because that's the way arrays are accessed. Okay. Normally the result will include the start index but exclude the end index, similar to what we saw in arrays. Right? So the concept is the same. Do you all remember that? When we created list, tuple, and all that, the same aspect applies. When I give something like this, it includes the start index but excludes the end index. Which is why we have this negative, because if I want to print something, I can't go from left to right because it will normally exclude something. But if I come from the last, it will include. Right? Different ways of accessing information, different ways of manipulating information. Clear? Right? So if I include 5 to up to the end, right? It prints 6, 7, 8, 9, 10. Clear? It prints from the start, up to 3. Can you see this? Different ways of accessing. You can even print a step, right? That is every alternate number. I am trying to print every alternate number stored in the array 1 to 5. Here I am trying to print an array, okay, the details in an array stored in the index 1 to 5. 1 means the second element. You are starting with 2. And I am including this step function, that is every alternate. You may have to do that, right? As part of processing. Every alternate, you may have to access and print, manipulate. When I say manipulate, what I mean is you may have to add something. You may have to subtract something, right? You may have to conduct some statistical analysis on that. So all of that is possible using step. Okay. What are the additional data? You get additional data types in NumPy. Okay, like integer, boolean, right, float, complex float, many other different types of data types are available, right? Compared to what? Because this is what you have when you create an array using tuple, dictionary, lists and all that, right? Whereas when you're using NumPy, you are getting additional integer data types, right? So you can use this depending on your need. Okay. So we also have copy. Okay. Can also have copy. Copy, is a new array. Okay. And the view is a view of the original array. Here in the copy, it owns the data and any changes made to the copy will not affect the original array. Okay. So please understand this. The view does not own the data. and any changes made to the view will affect the original array. So you need to know the difference between copy versus view. Again, this can be an interview question, right? What is the difference between copy versus view, right? So you will have, first you are importing NumPy as NP, right? So let me repeat this. Copy versus view. So copy is a new array, okay, and the view is just a view of the original array. So please understand this. So here in this example, I'm trying to replace the data that is stored in the 0th index. The 0th index is 1. So I am replacing it with 6. And when I print, in the case of view, it gets changed permanently. Whereas in the case of copy, the original value is retained. Okay. The copy owns the data and any changes made to the copy will not affect the original array. Please understand. Suppose if I am working on a data set and if I want to try out something, okay, and I don't want the original data set to be unimpacted, right? I don't want the data set to be impacted. Then I use copy, right? Because I can test something. Do you understand how this is applicable? Right? As I said, this is a classic interview question you all can expect. Someone will ask you what is the difference between copy versus view in NumPy and when will it be applicable? Okay. So the other one is what is called as a shape. It will return a tuple with each index having the number of corresponding elements. Right? It says it's a two-dimensional array. Right? And 5 elements are there. So it returns 2, 5. So this code returns what is called as 2, 5. Okay, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which means this array has got 2 dimensions and each dimension has got 5 elements. Do you understand this? Very, very basic concept. Like you are having a record, student ID and name of the student. The code returns saying this is a two-dimensional array with each dimension having 5 elements. Because when you are working on a larger data set, multi-dimensional data set, you need to know, right? What is the dimension? How many elements are there? Because you may want to access a particular element. So this helps. So quickly checking what is the the shape, right? What is the dimension? How many elements are there? I can easily get it using shape. Do you understand where it is helpful? Do you understand shape? I've given another example. So here I'm creating an array using the ndim keyword also. Remember we saw previously ndim can return the number of dimensions in my data set. Okay. Similarly, ndim can be used to create an array also. Please understand. As I said, in all our work, we are trying to manipulate data. We are trying to access data. We are trying to store the data. Because the patterns are all represented in the form of numbers. Let's reflect on the original objective. Our objective is to understand the pattern. Our objective is to understand the pattern. And all the patterns are represented in the form of numbers. And numbers are stored as arrays, right? Stored in the form of tables. We are trying to access them. We are trying to do some analysis. We are trying to manipulate them. So, shape helps us to find, understand, the dimension in the array and how many elements are there in each dimension. And similarly, I can create an array using ndim keyword also. I can use ndim to understand how many dimensions are there in the array. Okay. I can also reshape an array. Okay. So if you see this, it is written as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I am creating a 5-dimensional array, okay, with 2 elements in each dimension. Can you see this? 5 comma 2 is 1, 2, 3, 4, 5, and each having 2. Can you see it? I am reshaping. By reshaping, we can add or remove dimensions or change the number of elements in each dimension. My objective is to reshape my array. So for this, I use reshape. You all can understand. We saw copy versus view. We saw shape, right? Reshaping. This is all very easy. In the conventional way of creating programs using tuple and all that, these activities are a bit difficult. You have to write few more lines of code, right? Whereas here we are just using a keyword reshape and it gets implemented. Are you able to understand, right, where this all fits in? And when we started, right from the time we started Python, we learned to write simple codes, right? Then we saw creating types of arrays, right? List, tuple, and all that, dictionary, and all that. So once we have seen that, then we saw how to use if then else if, and else statements. Because I want to manipulate, I want to check what is there in my table. So I want to check what is there in my records. Another way that we saw is NumPy. So that's what we are seeing in this session. And we also saw the concept of writing functions. Remember, we said some of them are pre-built. So this NumPy is actually a pre-built. Someone has actually written it and providing it to us, literally on a platter. You don't have to write. So someone has made the job easier for you, right? And you are making use of this NumPy library. This is a pre-built, which is why you are importing the pre-built library. See, you are not writing any codes here. You are not writing any codes here, right? You are just importing. And pandas that we are going to see in subsequent sessions similarly is pre-built. You're going to see matplotlib, that is used to create graphs, right? Even that is pre-built. So someone has actually written the code for you. So all you're going to do is you are just going to import. If you see in Python, right, there are many libraries available that has made our lives a lot easier. The lives of programmers a lot easier. Such pre-built libraries were not there some time back, right? So today you have pre-built libraries for everything and anything, which is why understanding the concept is key. If you are able to understand the concept, because we have many pre-built libraries, you will be able to use the pre-built library and then manipulate it and get whatever kind of result you want. Right? This is definitely a luxury for this generation of programmers. But please understand the concept is very important, which is why in this series of sessions, we first introduce the concepts and then you are getting into the programming. As I said, pre-built libraries is a boon for this generation of programmers because it has taken away a lot of work. The heavy lifting has been done by someone else, and it is available as a pre-built library. Okay. Can we reshape into any shape? See, an array of size 10 cannot be shaped into 3, 2. You understand? Because some elements will be left out, right? Where will I put it? Whereas I can put, because there are 10 elements, I can put it as a 2 by 5 or a 5 by 2. I can't put it into any other shape. Do you understand? It is prompting, saying it's an error. So an 8 elements one dimension, you can reshape into 4 by 2, right? But I cannot reshape it as 3 by 3. Do you understand this? I have 10, right? I have, let's say, 10 balls. I can't put it in a 3 by 2, right? Because some balls will be left out. Where will you put it? You have to define, right? A 3 by 2 can hold only 6 balls. I have 10 balls. So where will I put the remaining 4 balls? So it is not possible. Okay. Reshaping is allowed only when all the elements in your existing array can be fitted into the new array. Do you understand? So we have seen shaping and reshaping arrays. We can also reshape a higher size dimension to a lower size dimension. What is called as a flattening of the arrays. I use reshape -1, right? This is a 2-dimensional array. I am making this as a 1-dimensional array by using the negative number in the parenthesis. This is also helpful for us. Moving on, we saw shaping and reshaping. Now let's look at how to iterate the arrays. Because as you know, iteration is an important concept in programming. So here we are seeing iteration in the context of arrays. And this is done using NumPy, right? Because this is an array. So you start with importing NumPy as NP. You're creating an array. And then you say for x in array, print x. Right? The other way is first print x and then print y. It prints as continuous numbers, as you can see here. Whereas here it is printing as an array. Can you see the difference? Again, it depends on your need, how you want to process it. You just saw this, right? For x in array, print x, it prints as an array itself, and here it is printing as continuous numbers, which is the elements in the array are printed first, and then the elements in the other dimension of the array are printed. That is, the elements, the first dimension are printed first, and then the elements in the second dimension are printed. Do you understand this? You can also iterate an array using the function enditer. Okay. Sometimes when you have nested iterations, right, that is repetitive iterations, it is very difficult to manage things, with the typical for loops, right? So enditer is a very useful one. Okay. This is much easier to manage, right? This is another way of iterating in the arrays. So we are creating an array, and now for x in NumPy np.enditer array1, I print. All the elements in the array are printed. Okay, and you can using editor, you can even change the data type in the array and then print it. And you can do it in a loop also. So that's the advantage here. So when you are doing it, you are specifying the type. Here we are converting into a string, and we are using this flags equal buffer because here these are numbers, right? They are stored in some place. Now when you're converting into string, new space in the memory need to be created, right? So which is why we pass this flags equals buffered, so that this enables the extra space, okay, for processing. Okay, do you understand? This is converted, these are numeric types, it is converted into string. You see this appearing in column. Okay, this is converted into a string. You can also stepwise, that is every alternate number that is present in the array can be printed using editor. As you can see, there are multiple ways of iterating, because iterating is one of the key concepts in program. Here we are talking of iterating within arrays. You can either using for loops you can do it, or you can use editor, right? So we have seen shaping, we have seen iteration. Now we are going to see joining of arrays. The keyword, the command that we use is concatenate. In fact, concatenate, is a synonym, right, for adding two strings. Okay. So joining arrays is an important concept, right? Because remember, the data that represent the characteristics of patterns, which we are trying to uncover, they are stored in the form of tables in databases, which is why we are spending so much time in arrays. So as part of the process of uncovering the patterns, we may have to add arrays, we may have to, in fact, there is a way to split the arrays. We are going to see that shortly. So we can identify the patterns. So all these functions are important, like shaping, reshaping, joining, splitting, all these are important concepts, because I use all of this to understand the patterns in my data, right? Because the characteristics which lie behind the patterns are represented in the form of numbers, and these numbers are stored in the form of tables in databases. What is a table? How do you, an equivalent of table is an array, which is what we are trying to process, right? So there are commands available in SQL, which is structured query language, the language that is used for the purpose of databases. We can join arrays. So here we have created an array. AR1 equals this, AR2 equals another array, and now here we are adding two arrays, right? And now you are printing. You can also mention the axis along which you want to add the arrays. If the axis is not explicitly mentioned, it will be taken as 0. When you take axis as 1, you are creating a two-dimensional array. So here the concatenation happens along the axis as 1. Do you understand? So I have joined two arrays and I have created a new array. I can also join arrays along horizontally and vertically, right? And along depth, along height, right? In this case, this is a simple array. In this case, it is a simple array. Here I'm adding the two arrays along axis equals 1, right? Here I am adding horizontally hstack. Here I am adding vertically, and here I am adding by height. Can you see the difference? Can you see the difference? And you can see the output is, here it is horizontal, here it is vertical, here it is depth. Can you see the three different types of outputs that have come? So here I am adding the array, right? Using np.stack. I can add arrays using concatenate also. We saw that earlier. And here, when we use the stack, the advantage is we have the option whether to identify whether it is horizontal or vertical or depth. In concatenate, we can mention the axis. So even here we can mention the axis, right? But instead of mentioning the axis, I can mention whether it is horizontal or vertical or depth. So I have multiple options to create new arrays from two different arrays. You understand? So the opposite of join, I mentioned that previously, splitting. So here I am, see there is an array here. It says split it into 3, right? Using the keyword array underscore split. But if you see, it has splitted, okay? There are 5 elements. You can't split it equally, right? Because there aren't enough elements, or the dimensionality issue is there. When you use array underscore split, it will take care of the dimensionality and print it, right? Because these two are 2 dimension, whereas this is a single dimension. The other way of splitting, okay, we can just use the word split. But when you use the word split instead of array underscore split, the dimensionality needs to be taken care. If I use np dot split, okay, instead of array underscore split, I will actually get an error because the dimensionality is not taken care. So please understand this. So just like adding along vertical depth and all that, okay, splitting is also possible vertically and depth-wise. All of this helps us to manipulate the arrays. Get it? You can also search for a particular element in there. See, it is telling where AR equals 4. Where is it? It is here. So it mentions the index. You understand? You can also ask print, okay? Print, where the number 3 is stored. It says it is stored in 2nd position, 5th position and 6th position, right? You can search for odd numbers. See the conditional statement. AR percentage 2 equals 1. When AR percentage 2 is 0, it means it is an even. You search where even numbers are there. You search where odd numbers are there. You can also find the index where a particular number is to be inserted. Right? You can find an index where a number is to be inserted, but search from right. Side equals right. You understand? All these things are possibilities. You search for a number, you search for a string, right? You can replace a string. You're trying to manipulate the array for the purpose of identifying the patterns. Okay. We have seen adding arrays, we have seen splitting arrays, we have seen iterating in arrays, we have seen how to search for a particular number or a string in an array. Moving on, you can sort an array also, right? Because when, let's say I have a table in which ranks of students are mentioned, I want to sort the array in descending order, or I want to sort the numbers in ascending order. So I use the keyword sort. You understand? In this case, can you see when I say sort here, G comes first, M and then O. Here it is 1, 1, 2, 3, 5, 8, 9. I can also sort a two-dimensional array, not just a single dimensional. So try all of this. These are the possibilities. These are the possibilities. When you're using Google Colab, even if you make a mistake, it is going to point to where you made the mistake, right? It is even giving you links where discussions for such errors are taking place. So you can learn all of this. But understand the basic idea is patterns. The characteristics of the patterns are represented in the form of numbers and characters, right? Boolean. All of them are stored in the form of tables. Arrays mirror the table. So you want to manipulate the table. So you want to manipulate the arrays. So you can understand the pattern. So you can uncover the patterns. Do you understand? So you can also filter an array using Boolean. Right? Here we are creating a new array itself using Boolean. Okay? Clear? So you are looking for odd numbers in the array. Right? Using the Boolean concept, it is coming as true, false, like this. You understand? In the first case, we are creating a new array from the array we created earlier, which is 1, 2, 3, 4, 5, 7, 5, 6, 7, 8, 9. The Boolean, which is basically true or false. For the odd numbers, 1 is true, odd number. 2 is even, so it is a false. Like this it goes. True, false, true, false, true, false, true, false, true. 9 is an odd number, so it is true. And then you are printing numbers where it is odd. So you understand? I can use this for even as well. Okay. So that's what I wanted to cover in NumPy. NumPy is an important library, right? Gives us a lot of methods, functions to manipulate the arrays, so we can uncover the patterns. Okay, so that's what I wanted to cover, and I will see you in another session. Thank you.